Hello grade 10s and welcome back to another video on electric circuits. In this video we're going to be looking at a question from the Department of Basic Education's NSC examination written in November 2018. This question says, consider the circuit diagram below. Now, here we have a complex circuit because this is not a series circuit, neither is it a parallel circuit. This circuit is called a combined circuit, and when the switch is closed, conventional current moves from the positive terminal of the battery through ammeter 1 through the 8 ohm resistor. Then, of course, at this point, we know that the current is going to divide. Some of it will go through the 8 ohm resistor at the top and ammeter 2, and some of it will go through the 8 ohm resistor at the bottom and ammeter 3. Then the current combines again and moves all the way past the closed switch to the negative terminal of the battery. We say that this 8 ohm resistor is connected in series with the battery. This 8 ohm resistor is connected in parallel to the other 8 ohm resistor below it. But this entire parallel connection is connected in series to the 8 ohm resistor. Now that sounds very confusing, but that is because this is neither a series nor parallel circuit, but rather a combined circuit. And you can clearly see that some information has been given to us about the circuit. Now they say switch S is open. Alright, so we can see the switch is open. Question 11.1.1 says, write down the reading on the following. Voltmeter 1. Voltmeter 1 is over here. It is connected across a 24 volt battery. We're referring to this as a battery because it consists of 3 cells. Since the switch is open, we know that there is no current flowing through the circuit. When there's no current flowing through the circuit, the voltmeter measures the EMF, or the potential difference across the terminals of the battery. Therefore, V1 will have a reading of 24 volts, and we can simply state V1 equals 24 volts for 1 mark. Question B says we need to determine the reading on ammeter 1. Ammeter 1 is over there. Ammeter 1 is supposed to measure current, but remember, the switch is open. So therefore, there's no current flowing through the circuit, and ammeter A1, which measures current 1, is going to equal to 0 amperes. It's very important that even when the value is 0, that you provide your answer with the SI unit. That's going to give you 1 more mark. Now we say, or now the problem says, switch S is now closed. So we can go back up to the circuit and we can close the switch. So that is going to disappear and the switch S is now going to be closed. Now they say, calculate the equivalent resistance of the circuit. Whenever you have a circuit like this one, the trick is to first determine the effective resistance in parallel, and then when you are done with that, you're going to add your resistor that is connected in series. So let's start with RP. This question is question number 11.1.2, so you write down 11.1.2. Did I write that down correctly? Yes, 11.1.2. Sorry, grade 10s. So now we say 1 over RP is equal to 1 over R1 plus 1 over R2. There are only 2 resistors connected in parallel here. So 1 over RP is equal to 1 over 8 plus 1 over 8. When we type this into our calculators, we end up with 1 over 4 or even 2 over 8. Remember, to obtain RP, which is the effective resistance, we find the reciprocal, which is 4 over 1, giving us the final answer as 4 ohms for the effective resistance in parallel. So what we are essentially saying is that this entire connection, these resistors, can be replaced by one resistor which has a resistance of 4 ohms. That is what we're saying. Now this 4 ohm resistor has a total current equivalent to the main current flowing through it. Based on that, we know that this is connected in series to this 8 ohm resistor. So we can now say that the total resistance is equal to, we can call it RS plus RP, which is going to be 8 plus the 4 that we just calculated, and this gives us a final answer of 12 ohms. The question is out of 4 marks, so you will most probably obtain 1 mark over here for your formula, 1 for substituting, 1 mark for saying 8 plus 4, and 1 mark for your final answer, provided that it has the correct SI unit. Now we can move on to the next question, which says calculate the reading on voltmeter 2. Now we've not been provided with any other voltmeter reading, besides of course the voltage or potential difference that is over here. So here's V1. V1 measures the potential difference across the battery, and therefore we can call it VT. We only have that potential difference, and we know the resistance of the resistor across which V2 is connected. So we're trying to calculate the potential difference here. This over here is a circuit or an equivalent circuit where the potential difference is going to be divided. Some of that potential difference is going to go over there, and the rest of it is going to be provided to this part of the circuit. Okay, it's sort of as though if there are only 2 resistors connected in series. Okay, now in series we know that to calculate V2, so this is question 11.1.3, we can make use of the voltage divider formula and say that V2 is equal to, I'm going to call this resistor R2 so that we don't get confused. So it is equal to R2 divided by the total potential difference, right, multiplied by VT. The total potential difference is 12 ohms, and VT is of course 24 volts. So we're going to sub in 8 divided by 12 multiplied by 24. When we plug this into our calculators, we obtain a final answer of 16 volts. So this is going to give us 16 volts. Okay, so for this specific calculation, I see that it is out of 3 marks. It might be that they're giving you a mark for the formula. This formula, however, is not provided on your formula sheet, so you must learn it off by heart. Then we have the substitution, and lastly we have the final answer in volts. So please do learn this formula off by heart, just in case they give you marks for it. And always remember that regardless of the formula, if there are subscripts to be provided, you best provide the subscripts. So 11.1.4 now says, how do the readings on ammeter A2 and A3 compare with each other? Well, we know that in parallel, the readings, the current is going to divide. So some current will go this way. So let's use a thicker pen. We know that some current is going to go this way, and some current is going to go that way. But notice that this resistance is equal to that resistance. So neither path is easier than the other. What that means, grade 10s, is that A2 will have exactly the same reading as A3. And therefore, to answer question 11.1.4, we can say that the reading of A2 is going to equal to the reading of A3. Alternatively, we can say I2, which is the reading on ammeter 2, is equal to the reading on ammeter 3. Or in words, you can state that they are the same. That's going to give you 1 mark. Now we go on to question 11.2. This question says, the graph below shows the relationship between resistance and the length of the conducting wire. So let's zoom out a little bit so that you can see the graph completely. On the left-hand side, plotted on the y-axis, we have the dependent variable, right? The dependent variable is always plotted on the y-axis, while on the x-axis we have the independent variable. The independent variable is always plotted on the x-axis. Now, the way I like to remember this was taught to me when I was in high school, and our teacher said we have a stick and we have a very heavy stone, right? So the I for independent, not for current, for independent is a stick, and the D is a very heavy stone. Now the wind is going to blow. Which one of these two is going to fall over? Well, the I is going to fall over. The D is going to stay standing. Therefore, current is going to be plotted, the independent variable, grade 10s, is going to always be plotted on the x-axis, while the dependent variable will always be plotted on the y-axis. That's a nice way of remembering where your independent variable goes and where the dependent goes. But I've gone a little bit off topic. Let's get back to the question. The dependent variable is resistance measured in ohms, and the independent variable is the length of the wire. Question 11.2.1 says, write down the relationship between the resistance and the length of the conducting wire. We notice here that we have a straight increasing line. This straight increasing line passes through the origin. In other words, when the length of the wire is 0, then resistance is 0. So yes, you may want to say that as the length of the wire increases, the resistance increases as well. But a better way of describing the relationship is to say that the resistance is directly proportional, because direct proportion indicates a straight increasing line that passes through the origin. So the resistance is directly proportional to the length of the conducting wire. For stating this relationship, you're going to obtain 1 mark. If you said as the resistance increases, the length increases, you're on the right track, but it doesn't take into consideration this part. Okay. So let's move on to question 11.2.2. It says, determine the resistance of the wire at a length of 30 millimeters. So we can clearly see here when the length of the wire is 10 millimeters, then that over there is the resistance. When it is 70, we have a larger resistance because, of course, as the length increases, the resistance increases as well. They would like us to tell them what the resistance is going to be when the wire is 30 millimeters long. So this is what we're going to do. We're going to find 30 millimeters on the x-axis. Then we're going to draw a line up to the actual graph. Now my line is not very straight, but you can pretend that it's a straight line for me, okay? And we're going to draw a straight line up from the x-axis at 30 all the way to our graph. From there, we're going to take a trip towards the y-axis, which is towards the left over there. And that is going to be the resistance reading. We see that the values on this y-axis are 0, 5, 1, 0, and 1, 5. That means that every 2 blocks represents 0, 1 ohm. All right. So let's read up. We have 1, 0. We have 1, 1, 1, 2, 1, 3, and this value is actually in between 1, 3 and 1, 4. So we're therefore going to say that the reading or the value of the resistance when the length of the wire is 30 millimeters is going to equal to 1,35 ohms. It's very important that you're always as specific as you can possibly be, and also provide your answer with the correct SI unit. That's going to get you 1 mark. Very 10s, we've reached the end of this video. Thank you very much for joining me.